Okay, let's start. So let's see one example for Fourier series. 如果我的 PowerPoint 没有动，再告诉我，好吧？The example here, f of x is equal to x minus x square. 你检查一下你的麦克风有没有静音？有人键盘打字很大声，自己注意一下好不好？So the function is f is equal to x minus x square. This is the first information. Second information is the range. X is from minus pi to pi. So x is from minus pi to pi. That means L is equal to pi. These two things are the same. Okay, these two things are the same. So I can only give you one condition. I can delete this one or delete this one. Okay, so if you see this one, you have to write down this one. Computer Fourier series. So that is means you have to find A0, AN, and BN. So use the equation. This is f of x, right? F of x here. Okay, and here is the range, minus L to L, and this one is 1 over L. So this is the equation. Put the L here, here, here. 3 parts for L. So L is very important. L is pi. So put the L here. Integrate f x minus x squared. Then it is a very simple integral. So just calculate. You can find this one, A0. About AN. So for AN, this term is F. This one is L minus L, 1 over L. Pay attention here. The angle for cosine, do remember, angle for cosine is K or N pi x minus L, right? The angle N pi x over L. And you put the N pi x over pi because L is pi. Originally, angle is N pi x over L. You put the L equal to pi here, so you can delete pi. You get an nx here. Then please to the integral. It is complex. Please do it by yourself. You have to do the x cosine and the x squared cosine. So you integral two terms and sum up two terms. You can get an answer. So first, you use integral by parts. You can get at least one. It's a long story, okay? After rearrange, please rearrange, you get at least one. And then cosine n pi is equal to minus 1. Order is n, right? Because you can see cosine n pi, if n equal to 1, If n equal to 1, cosine n pi is 1. If n equal to 1, cosine pi is minus 1. Is n equal to 2, cosine 2 pi is equal to 1. If n is equal to 3, cosine 3 pi is equal to minus 1. So you can find increasing n from 1, 2, 3, 4, 5. Your cosine value is minus 1, 1, minus 1, 1. So it is the same as you put this, right? It is minus 1 over n. If n is equal to 1 like this. If n is equal to 1 like this, you will get minus 1. If n is equal to 2 like this, you will get 1. If n is equal to 3 like this, you will get minus 1, right? So you can just replace cosine n pi using minus 1 over n. And combine this minus to this minus, you will get order n plus 1 here. Okay, so you get a an like this. Similarly, you can get a bn. Okay, so let's see bn. So for the formula, bn you have minus l to l and l over 1 over l here. And for bn you have to multiply sine. So again, you can see sine n pi, sine nx is from n pi x divided over L, right? If you put a pi as L, n pi x divided by pi is nx here. Okay, so the angle here is nx. So you can do the IBP again, x cosine and the x squared, x sine and the x squared sine. You can get this term. After rearrange, you have this one. Again, cosine n pi is equal to minus 1 over n. And then you can combine this one and this one, you have this one. So please give the final answer. Not only show the 3 coefficients, please give me the final answer here. Final answer. Final answer is f of x equal to 3 terms. The first, constant terms. Second, cosine term. Third, sine term. And remember, you can see this is the constant term, right? And the answer for constant is 2 over 3. But here it is 1 over 3. Because the formula here is, this term is 1 over 2 A0, if you remember. Okay, so 1 over 2 is important. Don't forget to put 1 over 2 here. So it is the answer, the Fourier series for f. Any question? Okay. Next, let's see the continuity. Recall what is the piecewise continuous. There are two requirements for piecewise continuous at a range from A to B. First, if f of x is continuous at all range. However, finite points of this interval are not continuous like this figure. You can see the blue lines are continuous, but at this point and this point, these two interval, this interval, and this interval, or these two finite points are not continuous. So that means piecewise continuous. For this segment, and this segment, they are continuous. But at this point and this point, it is not continuous. So it is called a piecewise continuous. Okay? And these two requirements are for the continuous. So if it is the definition, I think you know this, right? If f is from x0 minus means the point is from the left hand side to x. So that means the range is x0 minus h, but h is approaching to 0. When h is approaching 0 means x0 minus x0 minus h is approaching x0, right? So that means if this point is x0, x0 minus means from here, count here, from here to here, okay, from here to here. So x0 minus h, but h approaching 0 means h becomes smaller, right? And when h approaching 0, x0 minus h approaching x0. So from here to here. Similarly, what is x0 plus? X0 plus means x0 plus h, and the h is approaching 0. So if this point is x0, x0 plus means from here to here, from here to here, okay? So if the f of x is continuous as at x0, that means the left and the right limit, this one and this one. Okay, this one is left limit, this one is right limit. So left and the right limits both equal to f of x0. F of x0 means you bring x0 into this equation. That is continuous. Okay, so let's see some example. This one, f of x is composed of two equations. One is x, the other one is 1 over x. And the range is from -3 to 2 and 2 to 4. Okay, so here to here, -3 to 2. This one is f of x equal to x, y equal to x. This segment. And from 2 to 4, this segment is f of x equal to 1 over x. This one is this part. Okay, so this segment and this segment. This segment and this segment. Okay, from this one and this one. Which point is discontinuous? It is x equal to 2 because it is the overlapped point, x equal to 2, right? So during this range, x equal to 2 is not continuous. It is a single discontinuity at x equal to 2. How to verify? Please have this one and this one. What is f of 2 minus? F of 2 minus means you go from the, this point is 2. This point is x equal to 2. You go from here to here. From the negative part approaching 2, you will find the answer 2 here. Okay? And how about the f of 2 plus? That means you go from the right-hand side. This is 2. Go from right-hand side to 2. From here to here, you have this one. This one is 1 over 2. Because, so you have to show because f of 2 minus is not equal to f of 2 plus. Okay, you have to show f of 2 minus is not equal to f of 2 plus. So x equal to 2 is the discontinuity point. So the discontinuity point is 2. And to verify the discontinuity, you have to show f of 2 minus is not equal to f of 2 plus. Okay. Then, what is piecewise smooth? The last topic is piecewise continuous. Now it is piecewise smooth. Okay. What is the requirement for piecewise smooth? First, the f should be piecewise continuous. Then, to check smooth, you have to check f plan. Okay, to check f plan. So f plan should exist and continuous. That should be smooth. You can see this example. So please use the same function as last example. This function we have seen this before. Okay, and the problem is if the function piecewise smooth, and you have to verify. Okay, so just do this to check the property of smooth. Do the first differential f prime. Okay, so this is x, f prime is 1. This is 1 over x, f prime is minus 1 over x squared. Okay, then you have to check one thing. You have to check f prime minus 2. Sorry. You have to check f prime of 2. This point, the common point here. F prime of 2 is equal to 1, right? Here, 1. And, sorry, it is from the left-hand side. F prime 2 minus is equal to 1. How about f prime 2 plus? From right-hand side, here, right-hand side, it is equal to minus 1 over 4. Okay. So you can find it at a point x equal to 2. You bring 2 into f prime. You got a 1 and minus 1 over 4. You got a 1 and a minus 1 over 4. So they are different. F prime 2 minus is not equal to f prime 2 plus. So the piecewise smooth is verified. Okay. The next topic is convergence, Solian. Convergence of Fourier series. So for the series, for the infinite term of series, you can check the convergence. So firstly, there are two points. Okay. The first point is for the range from minus L to L. The second is for minus L and L. Okay. So pay attention here. This range means the solid point minus L to L, solid point. This one is the void minus L to L. Okay. So for this one, the x is range from minus L to L, but no minus L, no L. So the point minus L and L is here. Okay. So for this range, the series converges to this one. For every x, you just bring the you just get a value from left hand side and from right hand side and from left hand side. You sum up and divide it by 2. Okay, for this range. And for this point and this point, the end, to end, for this point and this point, the series converges to this one. You bring L from left hand side and minus L from right hand side. You sum up and divide it by 2. That means, what is this one? L from left hand side. That means you approach L, right? You approach L from left hand side. So that is L minus. Minus means approach from left hand side. Okay. And what is minus L plus? Minus L is this. What is plus? Plus means approach from right hand side. Okay. So you approach minus L from right hand side is this value. You approach L from left hand side is this value. You sum up and divide it by 2. You will get a value of convergence. You can see the example. Okay. Before see the example, you can see the property. At any point at this range. You can see it is small blanket. Small blanket means no minus L, no L. Okay, no minus L, no L. So if at this range, f of x is continuous at this range. Okay, then if it is continuous, that means from left hand side or right hand side, the value is the same. Okay, if it is continuous from left and the right hand side, the value is the same. So if you sum up this value and divide it by 2, you will find the same value f of x. You can see again. If this value is equal to this value, you sum up, you add this one to this one and divide it by 2, you will get f of x. Okay, the only value. You will get f of x. Okay, but if this point is a jump discontinuity like this one, if a point is this one, then the Fourier series will converge to the average of right and left limits is this point. So if you see the jump discontinuity, the Fourier series will converge to this point. Okay, it is the point midway in the gap, this one. Okay, then next, the Fourier series has the same sum or same converges to both ends. Is this one? It is this one. Okay, both ends minus L and L converges to the same value. Okay. So see the example. Okay. So let's see one example. F of x. This is the example in example 13.1. And we have got a solution like this, right? We have got a solution like this. Examine the relationship between Fourier series and the f of x. So let's see some information. First, do the first differential. Okay. First differential, you can find this is f of x. The first differential is 1 minus 2x. It is continuous for all x. So f of x is piecewise smooth. Okay, let's find the convergence. The range is from minus pi to pi. Range from minus pi to pi. So first you see this, no equal sign here. Okay, x is larger than minus pi, smaller than pi. No equal sign here. So this range. Okay, remember this range is this range. This range. So because it is continuous, so it is converges to f of x. So you can see in this range, the Fourier series is converges to here. This is f of x. So for the continuous equation, in this range, no equal sign here. The series converges to here. Okay, then at both ends, you just have this and this. What is this? This is pi. You can ignore this one. You can see pi. You just bring pi inside. This is the pi from left-hand side. Pi from left-hand side, but it is continuous. So no matter pi is from right-hand side or left-hand side, you just put a pi inside. So put a pi into x, you have pi minus pi squared, right? Pi minus pi squared. How about this one? This one you can ignore this. Just have minus pi. So bring minus pi here. You have minus pi square, right? You bring minus pi inside. Okay? After calculation, you get this value. So again, this symbol is a little complicated. You can try to ignore this part. You just see pi, you just see minus pi. Okay? Just see pi and minus pi if it is continuous. So bring pi inside. Bring minus pi inside. Calculation, you got this one. Okay, so two parts. For the convergence, you give me this range. You give me the convergence. Okay. Second part, you give me the value. You give me the convergence. So this is the convergence of this Fourier series. So for example, the equation may be find the Fourier series and find the convergence. So for a full example, you have to provide a Fourier series like this and provide a convergence like this. Then it is the final answer. Okay? And let's see the figure. As you know, it is an infinite series. So more turn to sum up, the figure will be more like the equation. I mean, you can see this one. There are two curves in this figure. This one is f of x equal to x minus x squared. Okay. The same curve are shown in three figures. Okay. In these three figures, the f is the same. What is the different part? Please see here. It is fifths, 5 turns. It is tenths, 10 turns. It is 20s, 20 turns. So you sum up 5 turns, you get this curve. If you sum up 10 turns, you get this curve. If you sum up 20 turns, you get this curve. Okay, so you can find the curve is more like just see like this range. The two curves overlapped much when more turns are used. Okay. So this kind of curve are obtained from your equation, from here. So just draw the curve by using this and use different turns. 5 turns, 10 turns, and 20 turns. You get a different curve, and you can find the curve comparing to the curve like this is more like when you use more turns. Let's see the last equation, the last example. It is the full question. Find the Fourier series and find the convergence. Okay, f is exponential. The range is from -1 to 1. So if you see the range is from -1 to 1, that means L is equal to 1. Okay, L equal to 1. Okay, let's see. First, find the Fourier series. So find the A0. Find the A0. So you just put the f of x inside. Range from -1 to 1, -1 to 1. Do the calculation, you have this one. Then find the an. Okay, find an. So an, f of x here, minus L to L, -1 to 1. And for an, you have to times cosine n pi x to L. This one is n pi x over L, right? L is 1, so n pi x over L is n pi x. Okay, and do the calculation. Please do it by yourself. Finally, find the Bn. Similarly, Bn, f of x is exponential. The range is from -1 to 1. Range from -1 to 1. Okay, and this value, n pi x divided by L, n pi x over 1, you get n pi x. Then this is the final answer. I want to mention one thing. It is -1 over n, -1 over n. So this one is cosine n pi, cosine n pi, okay? -1 over n is cosine n pi. So during the calculating process, you will get cosine n pi. And the final answer is to replace cosine n pi using -1 order n. So use these three coefficients, you get this Fourier series. Remember to write f is equal to this. And remember 1/2 here. So a0 here, right? And then the an here, you bring the common term outside. Also, you bring the common term outside. Then you leave the cosine and the n pi side here. This is the Fourier series of exponential x. The integral of exponential cosine and the integral of exponential sine is difficult, so please try to solve this by yourself and check if the answers are the same as shown here. Next, let's see the convergence. Okay, find the Fourier series first and convergence. So for the convergence, please divide the range into two parts. One is the one without equal sign. Second part is the two end. Okay, two end. So because exponential x is continuous, so between -1 to 1, no equal sign. Between -1 to 1, you get the f of x. Okay. And about two end, you bring 1. You bring x equal to 1 here. And you bring x equal to -1 here. And you sum up divided by 2. That is the value at two end. So when you give me the answer, I think this form is better. This expression is better. You divide the range into this part and this part. You divide into this one and this one, and you find the answer. Okay, you can see the figure here. This curve, there are two figures here. And this curve is f equal to exponential x. Okay, this curve. And we have Fourier series, right? We have series, and this is 30. 13th. So 30 turns you sum up together. You sum up this one for 30 turns, and you draw the curve. First, you can find at this range. At this range, okay, this range, the curve is similar, right? Because this range is convergence to this one. Convergence, this range from -1 to 1, no end, no equal sign, no equal sign here. From -1 to 1, you can find convergence is to exponential x. But for the two end means this point and this point, right? So for these 2 points, the convergence is the same. So you can find these 2 points are converge to this point. So you can calculate this value. This value will be very similar to 1.5. Okay, so again, you divide convergence to 2 range. The first range is no equal sign. No equal sign is this part. No equal sign this part. Okay, so no equal sign this range. The series will converge to exponential x. It is f of x. So converges very similar curve, but at two ends, x equal to 1 and x equal to -1, this end and this end, two ends, you will find the answer is similar and very different from exponential x. It is equal to this value, 1.5. Okay, so let me stop here. Let's continue I'll continue at Wednesday. 我们下一章上第7章，你也可以准备一下。Thank you。如果你记得留言，就可以下线喽。